Hello and welcome to this lesson on real-world problems involving square roots and cube roots. So we've previously had a lesson where we talked about estimating square roots, where we made some tables and we didn't use our calculator. We solved some equations, and this was in the last unit, or the last unit, I believe. So we're going to be doing actually a little bit more of that. It's going to be kind of very similar. So if you remember what we did before, this should be right up your alley. So you can see the essential question says, how do I use square and cube roots to solve equations? Did you know games like QWOP, Doodle Jump, Temple Run, and many more, they calculate how far you've traveled from some beginning point in the game. And to do this, they need to find square roots using this distance formula. And you can see the distance formula is there. And we talked about this once before when we talked about GPS and how it couldn't exist without square roots. Again, this is a situation where square roots are used in a lot of everyday life, and even more advanced video games. If you're playing a game on your computer and it says like 256 meters to a certain target, the way it knows how far you are from that location is it's doing this calculation very, very, very fast within the computer. All right, vocabulary. These are the two vocab words we had in that previous unit as well, square root and cube root. Actually, I think before they were perfect square and perfect cube. So square root is used to unsquare a number that is squared, like x squared. It always results in two answers, and we talked about that, how you always get a positive and a negative solution. A cube root is used to uncube a number that is cubed, like x cubed. And with a cube root, you always get one answer, and we talked about that before. We also made a table very similar to this. So if this is my number 1 and I square it, I get 1. 2 squared is 4. 3 squared is 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So this row are all perfect squares. If I was to square root any of these numbers, I would get back to this original guy. So 64, if I square root 64, I would get 8. Because 8 times 8 is 64. Down below, we are going to do cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 64, 125, and finally 216. We don't need to know those because they get very, very, very big. Like, I know this one off the top of my head is 1,000. But we don't really need to know the other guys. We need to know the perfect squares and perfect cubes. We need to know that if we cube root any of those perfect cubes, again, we would get back to the original number. And we're going to be doing a lot of this with our calculator. When we did this in the previous lesson, or the other lesson, we were not using our calculator. Here, I believe we are. So we want to solve this equation. X squared equals 16. In order to get rid of this x squared, to make it just plain old x, we are going to square root both sides. A square root and a squared are opposites, and they cancel, and we're going to get 4 and negative 4. I knew it was going to be 4 because the square root of 16 is 4. That was up in our table. The square root of 16, it's a perfect square. If we square root it, we get 4. Also, experience in calculator, if you square root 4 using your calculator, square root 16 using your calculator, you do get 4. And reminder that whenever you take the square root, whenever you take the square root, you do get a positive and a negative answer. We saw problems like this previously where the variable is not by itself yet. This is a 3 times m squared. So in order to get to the point where we can square root, We can only square root when it looks like this. We can't have any other junk with the variable, only the variable and the exponent. So to get there, we're going to get rid of that multiplied by 3 by dividing by 3. We're just solving equation. And when we take 27 divided by 3, we get 9. And then finally, when we square root both sides, m squared, when we take the square root of it, those two operations cancel each other out. And we get m equals 3 and -3. Okay, so this should be old news if you watched the previous lesson, or the other lesson that we did this in, not the one right before this. Go ahead and pause the video and try letters C and D on your own. When you are ready to continue, hit play and we will go through it together. All right, letter C. Very straightforward. There's nothing to it. We just are going to start by square rooting. And we're going to get x equals a positive and a -6. Letter D. In order to solve that, we are going to divide by 9 first. J squared equals square root of 225. Oh, what am I doing? 225 divided by 9 is 25. And then when I square root both sides, I get J equals a positive and a -5. And there we are. A little bit uglier problems. I mean, slightly different. So here, we're just going to do the same thing. We need to get the r squared by itself first so that we can square root it to get our variable by itself. Well, in order to make that happen, we're going to subtract 3 on both sides and get 4. We're going to square root both sides and get both a positive and a -2. My variable is already by itself. I mean, except for the exponent here. So I'm just going to start by square rooting both sides. But this is a little bit different than what we've ever seen before, I'm pretty sure. I mean, I'm going to get r equals, but as far as what I get over on my right-hand side, we can actually do this by hand. I mean, I can throw in the calculator square root fraction 64 over 25, and I get that. Decimal fraction, whatever. But what this is really saying, I mean, what the calculator is doing is it's doing this and this. We can break down this big square root into just the square root of the top and the square root of the bottom, which is 8 and 5. And do you know what the fraction 8/5 is as a mixed number? It's 1 and 3/5. Okay, so that's what the calculator is doing. It square roots the top and square roots the bottom. And again, because it's a square root, you need both the positive and the negative. I personally like the improper fraction better than the mixed number, but both are okay. Okay, so when you square root, you can square root like the whole top, the whole bottom separately, and then simplify from there, which you're going to need that for the next problem. So please do letters G and H right now. Pause the video. When you're ready to continue, hit play, and we will go through it together. All right, let's do it. Variable's right by itself. Square root y equals the square root of 4 is 2. The square root of 9 is 3. So I'm going to get the fraction 2/3 and -2/3. I did not even need a calculator. We are going to get the p part by itself. In order to do that, we're going to add 4 to cancel out that minus 4 first, giving me 49. When I square root both sides, my square root and my square cancel. They're opposite operations, and the square root of 49 is a positive and a negative 7. Right now, what are the 2 square roots of 169? Take a second and try that. Think about it. Pause the video if you need to. So the 2 square roots of 169 are 13 and negative 13. This is kind of to reinforce the idea of getting 2 answers, both a positive and a negative. So square root of 169 gives you both positive and negative 13. Now, cubes. So y cubed is 27. So just like with square roots, the way we got rid of something squared was by square rooting. The way we get rid of something cubed is by cube rooting. So you put a little 3 in that little corner of the square root box. So what's going to happen is, as we saw before, this cube root and this cube are opposite operations, and they cancel. And we're left with just plain old y equals. The cube root of 27 is, on your calculator, 3 second caret. Oopsie, I forgot to put a number on the inside. 3 second caret 27 equals 3. And there is no negative 3. Just 3. There's only one answer. The only thing you can multiply by itself 3 times and get 27 is 3 times 3 times 3. Just like we can square root fractions, we can cube root fractions the same way. So the cube root of this and the cube root of that. My cube and cube root are opposite, so they cancel. On the right-hand side, when I cube root, just like before, we can break this down into the cube root of the top and the cube root of the bottom, which is 1 and 2, 3 second caret 8 is 2. So we get the answer 1/2. 1/2, and I can check this answer. Check this. Watch. If I plug in 1/2 for t, so 1 fraction 2. Delete. Get out of here. There's where we want the parentheses. Okay, so 1/2 cubed. I put it in parentheses so it didn't just put the 3 on the 1 or the 3 on the 2. The whole thing is cubed, and that equals 1/8. So that's a way you can actually check your answers as you're going through, is see if it works. Okay, 2 for me and 2 for you. Go ahead and pause the video, try these 2 on your own. When you're ready to continue, hit play, and we will go through them together. All right, so we are going to start by dividing by 2 to cancel out the multiply by 2. W cubed equals 8. I'm going to cube root each side, and the cube and cube root cancel, giving me just W equals, and the cube root of 8, we actually still have it on the calculator right here. The cube root of 8 is 2. Letter D. In order to get the variable by itself, we're going to get rid of this minus 6 by doing plus 6, which is 1. When I cube root both sides, these cancel, and A equals, the cube root of 1 is 1. So fairly basic, straightforward problems, nothing terribly complex. It's just like square roots, but it works when there is something that is cubed. We do a cube root. 2 more here. Let's see. 2 for me. I just have to straight up square root this. There's nothing else to do. There's nothing to simplify. So those cancel, and C equals the cube root, 3-second caret of 216 is 6. Letter F. If we divide by 4, these cancel out. B cubed equals 500 divided by 4 is 125. We are going to cube root each side, and these cancel. And B equals 5. That is 3-second caret 5. Oops. 3-second caret 125. There we go. Is 5. Now, depending on what class you are, what calculator you have, you might have a slightly different steps to do this to do the cube root. Most calculators have a square root button just right on it, like this one does. So let me show you. Here's another type of calculator. So this would be a graphing calculator. And give me just a second because it's going to take over the screen here. To find where the square root and the cube root are not necessarily as straightforward. All right, we don't need that thing. Slide him off to the side. Here we go. All right, so if you got a big old fancy calculator like this, graphing calculator, this works for, I mean, any of the things that say TI-84. It doesn't have to be this exact looking one. Square root, you can see it right here above this x squared. So if I wanted to solve a question from above, here, if we wanted to square root 49, I can't just hit that button. So you see it's doing squared. Since it's in blue, we're going to hit the second button first. Second square root of 49 is 7. And that's what we got when we did it with our other calculator. So that's very much the same. But cube root is a bit different. Like there's no, even if you look at the blue things on your calculator, there's nothing here that looks like it'll do a cube root. There's nothing that looks like this button here where it has a little X root. So where we're going to find this is under the math options. And there's a lot of things in here. You can scroll up and down, and there's all kinds of things in here. And you can scroll over to the numbers and complex and PRB, and there's all kinds of different things in here. But the one we want was actually right here. Number 4. The cube root of. So if I hit number 4, either on the calculator, on the keypad, or I can cycle down to number 4 and then hit enter. Either way. That is doing a cube root. So if I was doing the problem we just finished doing, the cube root of 125 is 5. So that's how you use a graphing calculator, or at least a TI-84 calculator, to do a cube root. All right, and the caret button, like we normally did, like if we did like 6 to the 9th power, it's up here as opposed to being on this other calculator next to the 7. But they're largely very much the same. I mean, they're both from the same company. All right, but we're going to continue using this calculator since that's what most of you are going to be using. But I wanted to take a little second to explain on a different calculator how to do it. All right, so you are going to do these next 2 problems, letters G and H. Why don't you go ahead and pause the video, try these 2 on your own right now, and then when you're done, we'll go through it together. All right, cube root. Let's try it again. Cube root and cube root. These guys cancel. We get just k equals the cube root of 64. I'm going to break this down into the top and the bottom because I actually know these in my head. You probably don't. It might just be easier for you to do 3-second caret. Put a fraction in there. Do 64 over 216, which I'm actually okay with you doing. You should be able to do it. You're going to get that. Now, my way, in my head, the cube root of 64 is 4. Cube root of 216 is 6. And if I simplify the fraction 4/6, I'm going to get 2/3. Same answer, different process. Letter H, you cube rooted here, cancels. You cube rooted here, m equals, I don't know the cube root of 729 off the top of my head. I can take a guess, but I don't know it. So 3 second caret 729 is 9. Ooh, that would not have been my guess, actually. And I know the cube root of the top is 1. So this would give us the fraction 1/9. Problem solving. I mean, that was actually the part of this is actually doing some problem solving. We solved equations, but let's see how these same skills are used now in problem situations. So the volume of a cube can be found using this formula. Hint, hint, we're probably going to need that formula, where S is the length of a side. If the volume of a cube is 343 yards cubed, what is the length of one side of the cube? All right. So I can actually take the information they gave me and I can plug it into the formula. They told me the volume, 343. I can solve that now by doing the cube root on both sides. Let me move so I have space. There we go. So if I do the cube root here, these cancel. I get S equals. I'm trying to get the S. I'm trying to get S by itself. I'm trying to find out what the side length is. And if I cube root 343, 3 second caret 343 is probably 7. So each side of this cube is 7. And I can show that because, or prove it, because if I do 7 times 7 times 7, we get 343. That's length times width times height. And it worked. Sam and Allison are trying to find the side length of a square with an area of 100 centimeters squared. All right, so here's a square with an area of 100 centimeters squared. Sam's method is to take the area and divide by 4 to get a side length of 25. So Sam thinks we're going to take this and divide by 4, and then each side is 25. Allison's method is to take the area and square root it and get a side length of 10. So Allison thinks we're going to square root, and we get each side is 10. Do you see how sometimes even just drawing a picture of what they're saying as the problem's going on can make more sense to you? Like right now, just one of those pictures is clearly more right than the other. Do you know which one? Our question is to determine who has the correct method. Give a counterexample to show why the person with the wrong method is wrong. Okay, so is Sam wrong or is Allison wrong? Well, it's Sam. Sam is wrong because the formula for area, in order to find the area of Sam's square, area is length times width. If I take Sam's 25 times 25, I don't get an area of 100. If I take Allison's length times width, and I take 10 times 10, I do get an area of 100. So right now we can say Allison is correct. Okay, that's part 1 of our answer. Part 2 of the answer was give a counterexample to show why Sam is wrong. Can we give another example? Well, let's come up with a square of our own of side length 2. Nope, I'm not going to use 2 because, well, I think 3 would just be better. So if I pick a square the side length of 3, if we did area equals length times width, that would give us an area of 3 times 3 is 9. But using Sam's method, if we took 9 and divided by 4, it would say our side length should be 2.25, which is not correct. So there's a counterexample explaining, showing Sam again why his method doesn't work. And we have this whole separate page in here because, well, the words take up that entire page. Letter C. The side lengths of a square are x cubed feet long. The formula to find the area of a square is a equals s squared, where s is the length of a side. I want you to write a simplified variable expression for the area of the square. I want you to actually try this one first. I want you to pause the video, try this problem, and let's see what you get. If you get stuck or when you're done, hit play and we'll go through it together. All right, so let's see here. So it gives me information. It says the side lengths of a square are x cubed. So each side is x cubed feet. It then tells me the area for a formula is, oh, I almost put a 3, is that. Write a simplified variable expression for the area of the square. So if I plug in the side length for s, that's what you would do. After you have a formula, you plug in the information you know. So area equals x cubed squared. So here's my side length of x cubed. Here's my exponent of squared. And for me to simplify this, I would, distribute my exponent, outside exponent times by all of the inside exponent, and get x to the 6th power feet. That is a simplified variable expression. Letter D says, the volume of a cube can be found using the formula that. Yes, we know that. So if I have a cube, the volume formula is V equals S cubed. Cube A, ooh, I've got 2 cubes. All right. I'm just reordering and stuff. Okay. Cube A has side lengths of 5 squared. Cube B has side lengths of 3 cubed. Write the ratio of the volume of cube A to cube B. So the ratio would be a fraction, usually. So I would go, like the volume of A over the volume of B. So all I have to do really is plug in each of these side lengths into my formula and find the volume. So, volume would be 5 squared cubed. That's my side length. I'm plugging this side length in for S, side length. And then if I do the math, that gives me 5. I'm going to have to multiply my exponents, giving me 5 to the 6th power. For cube B, same thing. Side length cubed, giving me a side length of 3 to the 9th power. Now this answer I have here may be done, but I'm actually a little curious if this simplifies. I'm gonna type it in as a fraction. So 5 to the 6th power, 3 to the 9th power equals. Nah, it can't even change it to a fraction. So this probably does not simplify. In fact, now that I'm thinking about it, no, it definitely would not simplify at all. And 5 to the 6th power is pretty big. 3 to the 9th power, 5 to the 6th power is big. 3 to the, come on, 5 to the 6th power. Thank you. 3 to the 9th power. So they're both really, really big numbers. So they'd be like 15,000 something over 19,000 something. It doesn't simplify. I would leave it like we have here. Example 4, and this is probably the last problem. Yes, it is. What is the solution to the equation? Well, try it. Pause the video, do it. Let's see what you come up with. All right, so you probably started by dividing by 4, hopefully. Dividing by 4, b cubed equals 864 divided by 4 is 216. You either know from memory or using your calculator that you cube root 216, or you cube root both sides, and you get b equals 6, which was letter A. Hopefully you found that lesson to be fairly easy. Again, almost all of it was review or something we've done before, but it's an important skill that shows up multiple times, so we've done it multiple times now. Summary. When solving an equation with an exponent, what should you check for or do first before you square root or cube root? For example, here, what did we do before we did our square root or cube root? What did we have to do? And the answer is, we had to get the variable piece by itself. You had to make it like, instead of being like 3b to the 4th power, you'd have to divide by that thing and make it just, not to the 4th power. Instead of like 3b squared, we'd have to divide to make it just a b squared before we can do any square root business. So the variable has to be by itself. The only thing allowed to be on that side is the variable and its exponent. Okay. So thank you for watching this lesson, and I hope you reviewed and refreshed a lot of the knowledge. And until next time, toodles.